We're going to work on the trapezoids and the kites today. We did talk about, or I told you that an isosceles trapezoid was a special trapezoid where the legs were the same length. Okay, it has one pair of parallel sides and the legs are the same length. So there are another special trait of the isosceles trapezoid. So here's a nice picture of one where the legs are the same length. So that's isosceles. And that is that the base angles are congruent. Now, strangely, base angles does not just mean the bottom angles. It also means the top angles. So by pairs, the base angles are congruent. So in other words, angle D is congruent to angle what? Anybody can say it.
C.
C. Angle D is congruent to angle C, and angle A would be congruent to angle B. Hopefully you can see that visually, that would just make sense. But in a trapezoid, by pairs, the base angles are congruent. Base can be at the top, base can be at the bottom. If the whole figure was turned on its side, it doesn't even matter if they're on their sides. But the base angles are congruent. That can also be used to help us solve problems. Okay, so fill in that B is congruent to C, A is congruent to B. Okay, cool. All right. If you have an isosceles, these are very special ones. It has to be isosceles. This if with the extra F, the if. Okay, so if and only if is what this means. So that means that isosceles trapezoids have congruent diagonals, but also if you have a trapezoid and the diagonals are congruent, it means it's isosceles, so it goes back and forth both ways. We had only special types of parallelograms that had congruent diagonals. It's only a special type of trapezoid that has congruent diagonals. So that would mean, what are those congruent diagonals on this particular figure? Peyton, what's the diagonal on this? A to C, good, AC and BD. So those are our congruent diagonals, AC and BD. So that means that it's isosceles. If we know that it's a trapezoid, two parallel sides, and it's isosceles if those are congruent. So same length. Okay. Everybody's got that down. I know I didn't leave you a whole lot to write for these. Stop me if it doesn't make sense. All right. A mid-segment, okay, a mid-segment in a triangle went from midpoint to midpoint. A mid-segment in a trapezoid also goes from midpoint to midpoint. But it's midpoint of the legs. It's not midpoint of the parallel sides. That's not a mid-segment. So it's basically cutting it through the middle, and that mid-segment is also parallel to those sides. Yes?
Could that go for like a rectangle?
Okay, so a rectangle is a very special, and a lot of the things that will apply here could apply to a rectangle, but you'll see as we apply them that you wouldn't want to, because it would make your rectangle more complicated than it needs to be. So we want to make it used to make something simpler rather than more complicated. So we're just going to hold on these as being traits of a mid-segment for a trapezoid. It can be any trapezoid. It doesn't have to be an isosceles trapezoid this time. But as long as it goes from a midpoint to another midpoint, it's called a mid-segment. And so we need to talk about what it means to be a mid-segment, what the traits of the mid-segment are. And I said one of them already. I said that these are the parallel sides, so the mid-segment is also going to be parallel. So that's one of our traits. Okay? It's parallel. So that means EF is parallel to BC. EF is parallel to AD. Don't forget the parallel symbols are these. So BC parallel to this. Parallel to EF, and AD is parallel to EF. And so since they're parallel, happy birthday.
Happy birthday. Happy birthday. It's your birthday, man.
Because they did know.
Boom.
Okay,
18.
so,
Yeah. Wait, no, you're 19.
so
No
Naya
more
and
the minors.
Okay, yes. We had somebody walk in and it's his birthday. Okay, so EF parallel to BC, EF parallel to AD. And so that's one trait. The other trait has to do with the length of it. Okay, really what it is it's the average of the lengths of these two bases. So in other words, if you add this one plus this one and divide by 2, it gives you the length of that one. So it's the EF is going to be the average or the length of BC plus AD divided by 2. It works for any trapezoid. Now, what you brought up about the rectangle, yeah, the middle would be the average of the two, but since the two would be the same, you'd just be adding the same number and dividing by 2, it would be pointless because you'd just be able to look at it and see it was equal. But in a mid-segment in a trapezoid, one base plus the other base divided by 2 gives you that mid-segment. Okay?
ACBD.
Okay, good.
ACBD.
So of course, we're going to have to do some problems based on that. Okay? So here's a couple of problems.
Oh, I didn't get that down.
You didn't get that? All right, so let me back up. Yep.
All right, now I got it.
Okay, so there's a couple different things that can happen with these. Okay? Everybody got it?
Yes.
All right, so look at this problem. There's a couple things that can happen with that. We can do, the first one's a bit more simple, and then the second one is not so simple. So let's put that on here so I can write on it. Here we go, let's look at this one. Okay, so what am I going to do to find AB, the length of AB here? Who picked it up just from that theorem? Yes. Go ahead.
Add 10 and 19 and then divide by 2.
Good, so 10 plus 18 and divide it by 2. So what does that give you?
28,
Divided by 2 gives you
14.
14. Okay, so nice 14. So add them, divide by 2. That's great if you know both of the sides. Both of those top and bottom sides. The other one's a little bit more complicated, but not too bad. CD is our missing piece.
CD.
For those of you that like algebra, or even if you don't, I'm going to tell you the easiest thing is to give that a variable, so we can call it X or whatever your favorite variable is. And we need to set up an equation. Our idea is that if you add the two bases and divide by 2, it gives you the middle one. Okay, so let's set that up in terms of the variable. Anybody know what that would look like? Go ahead.
17 plus x divided by 2 equals 13.
Beautiful. 17 plus x divided by 2 equals 13. So then we need to use our algebra skills in order to get the x by itself. What do you want to do to both sides? Wait, I got somebody called on. Go ahead. Multiply by 2, perfect. So we're going to multiply by 2. And then do what?
Ooh, I know.
Go ahead.
Subtract 17 from 26 if you can't do it in your head.
Subtract 17 from 26.
If you can do it in your head, yes.
So what's the answer?
9.
9. Good. So CD is
Your
9.
math is so great.
9 plus 17 is 26, divided by 2 is 13. You can run through the check back in your head afterwards, or even physically write out the check to make sure that this plus this equals this. And so we can do simple problems, we can do more complex problems with them as well, because the next one is a little bit more complex of a problem. Pull this back up. We did that one. And then we have this one to do, so copy of it, put it over here so we can write on it. All right. All right. So this has a bit more happening. AB is 2x plus 5. So I can write that in, 2x plus 5. EF is 4x plus 3. CD is 13. So how do I set that up based on what we were just talking about? We're going to add two things and have it equal the midsegment. Add two things, divide by 2, and that equals the midsegment.
Mm.
So what goes where?
Where goes what?
Did you have thought?
Yeah, would you have to like find X first though?
Well, we're going to find X using this idea.
Mm.
So there's going to be X is going to be incorporated into this. Okay?
Yes. Smirks.
What do you think?
2x plus 5
Okay?
plus 4x plus 3
4x plus 3
divided by 2 equals
13. Good.
You can't just add it. You can't just add them together before. Like you can't just do 6x and then 8 plus 8.
If you knew that, if you wanted to, rather than putting it in, that would be fine. Okay? The only reason that I showed it like this is so that when somebody looks back at their notes, they can see what happened. So you said to do 6x plus how much?
8.
8 over 2 equals 13. And then we need to solve. So what do we do after that? Go ahead.
Divide 6x by 2, so that's 3x, right?
3x.
And then plus 4.
Plus 4. If you wanted to, yes, you could do that.
All right.
So he said he wanted to do 3x plus 4 equals 13 and go with that. That works out great as long as there's no fractions involved. Okay, so for the sake of just in case there's fractions involved, I'm going to go ahead and multiply both sides by 2.
Mm-hmm.
So you could do that, or you could do what you wanted to do. Both will work the same.
Wait,
So
I'm confused.
6x plus 8 equals 26.
I'm confused on how we got 6 and 8.
Yeah.
Because 2x plus 4x is 6x, and 5 plus 3 is 8.
Duh.
Thank you for asking.
It's okay. That's a great question.
It really is, because I don't want anybody to sit there and go, gee, I really don't know what to do. Okay? I used to do stuff like that. That was not a good idea. Like say, okay, I don't know what to do, but I'm embarrassed to ask, so don't do that, because that just gives you a headache later when you're trying to figure out. Okay? I had a teacher once in college who said, okay, you get to this point and then you plug and chug. And I'm like, okay. And then he said, and you get to this point, then you plug and chug and you throw the answer up on the board. And I'm like, I had no idea what plug and chug meant. So I didn't ask the question. And then after like several weeks, I realized what he meant is that you just keep working on the problem, plug away at it, and chug, meaning keep on going with it, and then you would get to the answer. But he didn't show any of the steps. He just threw the answer up there. I'm like, what is this plug and chug thing that I have no idea what it means? So, like I say, sometimes your embarrassment, if you don't ask, then you're like, okay, I really wish that I had just been brave and asked so that I wouldn't have to. I think it was even somebody finally asked after several weeks of that, and like, it was like, it's like, oh, that's all
Jump
he meant?
scare.
Okay. Wish I'd known that rather than cause myself a headache. All right, so this one, you know to do that. 26 minus 8 is how much? 18. 6x equals 18, so x equals 3. X equals 3, so if we need to find A, B, and E, F, since x equals 3, we need to then do what? Substitute. So we need to do 2 times 3 plus 5. So 6 plus 5, we get 11. Got to plug it in. So AB is 11.
Johnny. We tell me.
AB is 11, because we look up here, we have 2x plus 5 is AB. So 2 times 3 plus 5 gives you 11. EF, let's plug in for EF. 4 times what?
3.
3 plus
17.
3 gives you
15.
12 plus
That's what I
3
meant.
is 15.
I meant 15.
The other 17 that looks like a 15.
Yeah.
There we go, 15. So actually plugging it in and working until you get an answer,
Mm-hmm.
you could find that pretty easily. But don't forget to do the work, show the work, so that you don't fool yourself and write down the wrong answer. Okay, that one professor, he could have been putting wrong answers all the time because it was like, okay, he just was like throwing answers up there and it's like, oh, okay, figure out the steps on your own, you should have just said. It was an advanced math class, he really didn't need to show all the steps, but there we go. Okay, everybody got it?
Yeah.
All right. Moving right along.
Okay.
All right,
Yeah.
kites. In a kite, another trait of a kite is, yes, we know that you've got 2 pairs of congruent sides. Okay, they are not opposite of each other, but 1 pair of opposite angles is congruent. Okay, they are the ones that are made by the non-congruent sides.
Mm-hmm.
Thank you. Okay. All right, so these angles are congruent. Okay, if you think about the line of symmetry going down through the kite, okay, in other words, the line of symmetry cuts it into 2 pieces where if you folded it, you would get the same thing. Those 2 sides, those 2 angles actually have to be equal to each other. And interestingly, the diagonals share a trait that was also a trait in a rhombus, which would be that the diagonals are what?
Congruent?
The diagonals are not congruent.
I guessed anyway.
Okay. See what that was telling me. Diagonals are what? Did you have an answer?
Perpendicular.
Perpendicular. Good.
Mm-hmm.
So the diagonals are perpendicular. Those angles are congruent. The diagonals are going to be perpendicular, making a right angle, making right triangles. Right triangles are super important. We're going to spend significant time on right triangles after winter break. Okay, but super, super, super important. So knowing those facts,
Bless you.
knowing those facts, we can look at this. Okay, so the other one, though, actually, there's one more here. I'm sorry. Okay, the crossbar. Okay, I'm calling this the crossbar that goes from the one congruent angle to the other congruent angle. The other one is called the axis of symmetry that goes right down through the middle. That axis of symmetry will bisect those 2 non-congruent angles. Okay, that axis of symmetry will bisect the non-congruent angles. So this one up here will be congruent to this one right here. This one right here will be congruent to this one right here. And it's also going to bisect this crossbar. It's going to bisect AC. So it's going to bisect the angles, and it's also going to cut the segment into 2 equal pieces. Because this is like a piece that goes down and cuts the whole kite into 2 equal pieces. So the angles have to be equal to each other, as well as this piece that goes across like that. So we can write those in. AE is congruent to EC. Angle ABD is congruent to CBD. And ADB is congruent to CDB. So you have all of those. All right, now based on what you know, I'm going to give you a couple minutes to work on this. I'm going to put our friends online on hold and then we'll go over it. But take a couple minutes and work on that. Everybody who's watching it, pause and try to do it by yourself and then continue the video. Okay, so you need the clarification that on this, you're actually looking for how many degrees. So this FAL will be a certain number of degrees. LFA will be a certain number of degrees. So that's what you're looking for, and putting you back on pause. All right, so let's pick it up and let's go over finding out what we can find out, explaining why. So who can give me FAL?
I can.
What is it?
90.
It's 90. Because these pieces have to be perpendicular, so this one has to be 90 degrees. So then we have some other information. I want to put that in. I want to put in the IFA is 48 degrees. 48 degrees deciding in there. YIA is 62 degrees. Actually, wait a minute. Somebody had one in here that was not correct. This one right in here is not 62, just so you know. But we do have some things that we can go by. How about if we're looking for LFA? You can tell me LFA. Jordan? 48. You got the last one, so yeah, 48. How did you know? How do you know, Isaiah?
Oh, because it's congruent to to the other one.
Good.
Yeah.
Because these two are congruent, these have to cut them into 2 equal pieces. So now I want IFL. IFL. Here.
You have to add 48 and 90.
Not too much work. So I'm going to stop you right there. IFL.
Oh, IFL. Okay.
IFL.
48 times 2
Times 2
would be 96.
96. And that's your answer, right? 96, because there are 2 48s right next to each other, so that gives you 96 for that one. AYI. AYI. Then
38.
what did you do to find it?
I did 62 plus 90.
62 plus 90,
Yes.
which gave 152. Then what?
Then you subtract 152 from 180.
Good. 152 from 180. And you said that gave you
30.
38. Okay. AYI, we're going to go with 38.
Yeah.
And then we do LYI. So LYI coming down here and then up here. LYI. How are we going to find that one then? This is 38. Somebody different? What do you think, sir?
No thinking.
You're not thinking?
I say no thinking. I don't know.
Oh, don't know? Okay, so, yeah. 38 times 2. 38 times 2.
Oh, shit.
Because here's this and this one together, 38 times 2. Gives us how much?
76.
76. So this one's 76
I was thinking
degrees.
that for real.
I, Y, L. L, Y, I, Y, L.
76.
Also 76. It's just another way of saying the same thing. Okay, so that's just a review of making sure that you know what the order of the letters is telling you. And then fly, F, L, Y. So we have to do a bit more for that. Yes, go ahead.
Alrighty. So
Go ahead.
if 48
Uh-huh.
is times 2 will be 96.
Okay, I have to hear where you're going with that.
Oh wait, no.
Okay.
48 L and Y. So you have the other side of Y, which will be 38. Right?
38. So over here's 38 is what you're saying, right?
Right.
Here's 38, okay.
So you add 38, 48.
38 and 48. Okay, I see where you're going with this. 38 and 48, she said. 38 plus 48.
FLY, right?
FLY, yep.
And then
That gives us 86, right? Okay.
you subtract 86 from 180.
Mm-hmm.
Plus you
180 minus 86.
94. No.
Yeah.
but it's 94. So
94.
L equals 94.
94, good. So what she did in her mind, just for those that might have missed it, is she was looking at this large triangle that went all the way down through here, all the way over here, and then all the way across here. So she said 48 was here, 38 was here, and then since we're trying to find FLY, this one right here, she said add them and subtract from 180, that works. Okay. So filling in missing pieces, finding out what they're like,
I go dump this ice
using all
cream.
of those rules is going to help you. So that's that. We miss you, basketball team. Hopefully you're doing great. Say hi to everybody else.
Bye.
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 Mm.
See you soon.